Ever notice how, like, some of the simplest ideas end up being, like, the most powerful ones?
Mm-hmm.
Like, imagine you're at a party,
Yeah.
right? And you're trying to figure out someone's favorite music genre.
Yeah.
So you just ask the 5 people standing closest to them,
Yeah.
see what they like and kind of make a guess based on the
That
majority.
makes sense.
Turns out that's basically how a whole machine learning algorithm works.
Really?
Yeah, it's called K-nearest neighbors,
Okay.
or KNN for short, and we're diving into that today.
Awesome.
Straight from the sources that you provided,
That's right.
see how it works, where it really shines, and maybe even where it trips up a bit.
I'm excited for this one.
Yeah, this could be fun.
KNN is so cool because it really does take the simple idea
Yeah.
of checking with your neighbors
Yeah.
and turns it into like a prediction machine.
Yeah.
But the key is really understanding how it defines distance between beta points,
Okay.
because we're not always talking about like physical space,
Right, like in our party example.
Yeah.
It's whoever's physically closest to the person,
Exactly.
but how does that translate to, like, say, recommending a movie on Netflix or something,
Yeah, that's a great point.
you know?
So like instead of physical distance, it could be like how similar two movies are
Or-
based on, genre or the actors or directors.
Interesting.
All those factors kind of become part of the distance between them.
Okay.
And the algorithm uses that to find the nearest neighbors, which is the K in KNN.
Oh, that makes sense.
So if K is 5, you're looking at like the 5 most similar movies.
Okay, so we found our nearest neighbors now. How does the algorithm actually use them to, like, predict someone's favorite music genre?
Okay, so think of it like a mini election.
Okay.
Each of the nearest neighbors gets to vote based on their own favorite genre,
Oh.
and then like the genre with the most votes.
Right.
That wins, and that's the algorithm's prediction.
So simple, but so powerful.
I know, right?
Now, I know the sources mention KNN being, like, really good for smaller data sets.
Yeah.
And they say something about them being well separated.
Yeah.
What does that actually mean?
Okay, so picture all those music preferences like plotted on a graph.
Okay.
If all the rock fans are clustered together
Yeah.
and all the pop fans are like in their own group,
Uh-huh.
it's really easy to classify someone new just based on where they fall on that graph.
Right.
That's well-separated data.
I got it.
KNN does really well in scenarios like that.
So it's like if I landed in the middle of a country music festival,
Exactly.
it's safe to assume I'd probably like country music too.
Exactly. That intuition translates directly to how KNN works.
Wow.
And that's a big reason why it's so popular for recommendation systems.
Oh, so that's the connection the source was making
Yes.
with, like, those, because you watch Stranger Things suggestions on Netflix.
Exactly.
KNN might be behind that.
It could be. Yeah, absolutely. And companies like Amazon use similar algorithms too.
Wow, that's so cool.
It's all about finding those nearest neighbors in a sea of data to figure out what you might like next.
I love that analogy. A sea of data. That's great.
Lots of data out there.
Okay, now the sources also mentioned that KNN can struggle with something called
Yes.
high dimensionality,
Yes.
which sounds kind of intimidating.
It does sound a little scary.
What does that mean in plain English?
Okay, so remember our party example?
Yeah.
Works in 3 dimensions. Right length, width, and height of the room.
Yes, 3 dimensions.
But imagine trying to find the nearest neighbors in a room with, say, 10 dimensions.
10 dimensions.
Yeah, that's kind of what we mean by high dimensionality.
You know.
Dealing with data that has many different features or variables.
So it's not just about physical space anymore.
Right, it's about complexity.
Got it.
And that complexity causes problems for KNN because in really high dimensional spaces, the idea of distance, it becomes less meaningful and the algorithm can get less accurate.
And I'm guessing it becomes a lot more computationally expensive too, right?
Yes, definitely.
Like trying to calculate the distance between every single point.
Yeah, you got it.
In a 10-dimensional space.
With massive data sets and tons of variables,
Right.
the calculations KNN needs to do can get out of control pretty quickly.
Yeah. That makes sense.
Something to keep in mind for sure.
So it's like KNN is that friend who's amazing at intimate gatherings,
I like that.
but maybe gets overwhelmed at a giant rave,
Makes sense.
you know?
Yeah.
Powerful and intuitive for the right situation,
Yeah.
but not a one-size-fits-all solution.
Definitely not.
Now, this has got me thinking, we've talked about movies and music,
Right.
but where else could you use KNN?
That's a good question.
Like, could it help doctors diagnose diseases based on similar symptoms?
Potentially.
Or maybe predict stock prices based on historical data?
Yeah, it's possible.
Food for thought.
Definitely.
I'll leave you with that.
Sounds good.
Keep diving deep.
Always be diving deep.